Hey, how's it going, everybody? I was reading the messages, didn't even realize I was online. Haha. How are y'all today? Did anybody go anywhere for the 3-day weekend? He said, knowing that no one's allowed out of the house to go anywhere. Yeah. I went to the backyard. How's it going, Sala? Tanya, hello. Is it Skirler? I'm glad that you were able to make it tonight. It'll be all right. I haven't been doing anything. Had a birthday last week. Very happy about that. My wife gave me something really cool. Been wanting this for a long time. I love these pop vinyl figures. So I finally got the Lorax. You made a TikTok? Yeah, I have a TikTok. I'm more of a creeper and not a actually creator. So I just watch TikToks. That's all. They're fun. And thank you very much there, Saba. It was a pretty good birthday. Like I said, got my Lorax. And despite the fact that, I'm an apes teacher, I had a really good steak. Yeah, it was good stuff. Anyway, I guess we should start tonight. I guess everyone can hear me, so that's cool. Everyone have a decent week? Anything exciting going on? Nope. Well, hopefully tonight will be. Well, hopefully it's not the highlight of your night or your day because I'm not that interesting. But I'll try my best. I did dye my beard green. It faded out really, really quickly. So I'm gonna have to do that again. So hopefully next week it'll be really green and not just really. It doesn't even look green anymore. All right, let's just get this underway, shall we? Let's have a little bit of fun. Let's talk about Unit 3. It's a hint of green, but I want it to be like green. So I'll have to work at it. The gray turned green rather nicely and faded after a couple of days. So I'll keep working on it. Anyway, as I said, tonight we're working on APES CRAM session unit number 3, all about populations. This was actually some of the topics of my very first stream with Fiveable. I was really excited about this. Or at least my very first ones that I really liked, because I kind of like talking about the first section of this, which is some of the ecology stuff a little bit still. Anyway, so don't forget, of course, we have our weekly stream calendar going on. APES, of course, is on every Wednesday, except for our CRAM sessions, because y'all are extra special people, and I love you to death. Our CRAM sessions, of course, are on Monday nights, but our normal weekly, just regular streams are, of course, on Wednesdays at the same bat time. And of course, I went too far. This week, actually, there happens to be 2. In the afternoon, 3 p.m. Eastern or 2 p.m. my time, which is Central, we're going to do a FRQ review of the 2016 FRQ. So one of our people are going to be looking at that, talk about tips and tricks and such. Then later on that night, we'll be talking about population dynamics and age structure diagrams. Basically, very similar to a section of what I'm talking about tonight, but since it's only concentrating on those things, they're going to go into a little bit more detail. So that will also be good. So even again, if you watch tonight, I would still attend Wednesday night because, like I said, she'll have a little bit more detail. And then, of course, next week on April the 20th is our next CRAM session. Okay? So who's ready to have some fun tonight? Who's ready to have some fun with Think Fiveable? Yes, I realize the coincidence on the date there. Alrighty, so let us begin a little bit. So this is what I plan on covering tonight. It is quite a lot, but we can get through it. I've trimmed down a few things. I've got to the basics, the nitty-gritties of things that you need to worry about. And of course, at any point in time that you have a question, please pop it into the chat. I try to watch it as closely as possible, just to make sure that we get all questions taken care of. Or you can click on the Ask a Question button at the bottom and type your question in there. That works too. I'm cool with it either way, whatever works for y'all. Okay? So, Let's start off with what is the difference between a generalist and a specialist when it comes to a species. And I have a couple. I just made this little chart. Like I said, I tried to boil things down a little bit. So I like to come up with ways to raccoons or which one there, Tanya? Which one is the raccoon there? I try to come up with different funny little ways to remember. I like jokes. I like comedy movies. My wife is all about the serious and the romance and the scary. I like movies that go pew 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 and swords and comedy. So I am all about trying to make things easy for myself to remember by putting a little comedic twist to it. All right, excellent time. Raccoons are your generalists. They are one of your best examples. Excellent, Emma. They can adapt. Well, yes, they can adapt to almost any situation. They're pretty good at it. Polar bears are a specialist. Yes, most definitely. So I came up with nicknames for these a while ago. Think of the generalist as a jack of all trades, whereas the specialist is a master electrician. Jack of all trades, like you guys have said, basically can do almost anything. They're very broad in their abilities. They're not pinned down to anything, whereas the master electrician, our specialist, that's all they do. They're very good at that one thing and not very good at anything else. Okay. Excellent, Jacob. Wow, you guys are already on the ball with all this. Sweet. Yes, Dakota Pigeon is definitely going to be a generalist right there. Let's see. Jacob says generalists can tolerate a wide variety of biotic and abiotic conditions. Righteously good on that one. Tiny generalists, basically anything and everything. Yeah, they do. While specialists are very few items. Excellent. So look at our niche and our dietary restrictions here. Hummingbirds and bees are going to be specialists. Yes. Yes, they will definitely be specialists there, Tanya. So a niche is basically its role in the environment, everything about it that makes it what it is. Generalists are very broad. They can go into lots of different little corners of a niche, whereas the specialist is very narrow in what it can do. Again, it's can only do that one thing very well. Generalist tends to be advantaged in habitats that are changing. Well, I think, Jacob, you already got a copy of my slideshow presentation because you're going right into a lot of the things right there. That's awesome. Dietary restrictions, specialists are more about fine dining. They only like a few different things. Whereas generalists, if there's a feed trough, we're good for it. Let's do it. Think of it that way. Locations in the world, generalists, you can find them in lots of different habitats, whereas the specialists, you may find them in lots of places, but they're very specific places for very specific conditions. Generalists, they are all about going with the flow. If there's a change in the environment, they are not usually the one that is going to be affected. All right, now, Tanya asked for the invasive thing. Which one is going to be invasive and which one is going to be affected by invasives? More often than not. That is correct. Usually you tend to see that your generalist species are more invasive than the others. Man, I am so happy with this crowd participation. I cannot tell you. I had to check in with my fourth period class like I do every Monday and Friday. And y'all are giving me so much more feedback than they do. So much more. I thank you for that. Oh, so you're going into the KNR species. That's my next slide. All right. So again, our species examples are going to be the raccoon, also known as the trash panda. And the specialist is the actual panda. There's lots of different examples of those. But like you guys came up with already, you had like the hummingbird and the bees. All right, Tanya says that the specialists are going to be case selected. Few kids, lots of kids. So do y'all even need me tonight? I'm thinking I don't need to be here because you've got this down pat. I'm so super happy about this. Oh yeah, I'm all about reinforcement. Don't worry, I'm not going anywhere. I promise you. I promise you, I am not going anywhere. We're going to cover all this, and anybody needs reinforcement. I tell my students all the time, you don't learn something just the first time looking at it. You've constantly got to be, kill drills. Like that's why math classes, you're constantly doing the same type of math problem over and over again so you understand how to do that math problem. If you just look at something one time, you may not understand it. Look at it again and again and again. All right, so let's go with our KNR species, right? So it's always a capital K and a lowercase r. Uh, if you look at my presentation over this earlier in this year, talking about population dynamics, I kind of go into why it's K and R. I'm not worried about it tonight because it's nothing you have to worry about. It is not going to be on the test at all. Oh, you Google the heck out of the unit. Hey, that's not a problem. All right. That's not a problem. If you don't understand something, you definitely want to have reinforcement, like you said. All right. So sizing, usually your K species are going to be larger. Usually your R species are smaller. The K species, they love their kids forever. They have this, if you want to think of it, an emotional attachment to their kids. Whereas the R's is like, it's time for you to go, right? Get out. Yes, as a species, humans are K species. Now we have individuals that could be R's, okay, but as a whole species, and that's what you have to look at. You have to look at the populations. You have to look at the species, not individuals. And you're right. So humans are going to be that K. Okay. So family size. Usually the K species have very small families. As it is, they're very large creatures anyway, or tend to be larger creatures. So that's a lot more food they have to feed their kids and all that. Okay. One, I believe what she means by major grades is probably test grades. Yeah. Now, our species, they have lots and lots of kids. Think of the cockroach. Lots of kids all the daggum time, right? We're going to get to the survivorship curves as well. I think that is my next slide right after this one. Jake, I really do think you're spying on me. I don't think I have a camera in here. Nope, just a Guardians of the Galaxy poster. All right. So, competition. The K species, they are very competitive because they need to have what little resources they can get. Whereas our species, they're more of a generalist. They'll just take anything they can get. Yes, you can see me through the camera, but you can't see my, all the tabs I have. I'm not that dumb, Tanya. I'm dumb, but I'm not that dumb. Although that's kind of the same thing I would have said to my students. He was like, you got a camera right there. Duh. All right. So in succession, which we talked a little bit about last week, intuition, it could be that too. Or like you guys said, this has been, hammered into you a lot. So that's cool. I like that. It means we're going to get a lot more done tonight, which is cool. Because I do have some math for y'all to do. All right. So when we talk about succession, usually what we see with, yes, and don't worry. Hey, I'm not a big math person, but I'm going through it step by step. It took me about an hour to go through you're going to see the math problem is really easy or easier. Let's go with that. It took me an hour just to make it so that you can understand them. Okay. So I got you covered. All right. We're not sure about the math on the APES test. Okay. So we're still trying to get some confirmation on all that, but I'm going to show you as a reader, what we're expected to see when it comes to math. Okay. All right, so late stage succession, because again, they're larger creatures, we're going to see them in those later stages of succession, whereas your R species, since they can reproduce rather quickly and they're rather small, don't need a lot of resources, and they're kind of generalists, they will be your early stage pioneer species or early stage successors. Now, again, I think you guys have already answered this. The K and the R, which one is invasive and which one is affected by invasives? Tanya, that's a good thing. Yes, keep a calculator handy just in case. Your phone should work, but I have one piece of information on that. All right, K is the affected and R is the invasive. Boom, baby, that is awesome. Yes. Once again, because that generalist thing, R's are tending to be more of the invasives because they can go anywhere, fit almost any little niche or a wide variety of niches. Let's go with that. I know spelling and keyboard, the S and the, they're really close together, Tanya. It's all good. I know what you meant. All right, so examples of Ks and Rs, humans and elephants, those are rather large creatures. Very few babies, except for the Duggar family. And they take care of the kids for the most part. When you're looking at the R species, of course, and lots of people just go to just like animals. But think of it this, the Duggar family, that's 19 and counting. It was on, what was it? I don't remember which channel it was on. I think it's Duggar, but it could be ER. Yeah. It was a cultural reference from a couple years ago. But like I said, when people are talking about Ks and Rs or generalists and specialists, they tend to think of the fauna or the animal examples. But don't forget, plants are also in this discussion too. Okay, flora being flowers and plants. So that's why I put grass on there. If you think of it, grass is going to be one of those lovely little generalists. Okay, they're very small. They can fit lots of different little niches and all that. Moss, yes, Tanya, moss would be another rather good example near any of the damp areas because moss does need some moisture in it. Yes, moss would count as the R, most definitely. Now, I know what you're thinking to yourself. You're thinking, is it going to be a K or an R? Some places, some things, they don't really fit that model. They can have R tendencies or they can have K tendencies. So it's not like a two circles. You're either a K or an R. There can be some overlap. That's kind of it's an expansive type thing. It's a spectrum if you want to think about it. All right. So when you don't fit the K or the R, you can have characteristics of both as a whole species. So look at this turtle right here. Okay. Or let's look at trees first. My bad. Let's look at trees. So trees, very long life, high competition because they're competing for water, nutrients, and all that. So those right there, that makes them a K species. But they have insane amounts of kids. Look at all the seeds that they're producing. You can find certain trees all over the planet. That will put them into the R category. So they have characteristics of both. So if if a question is asking you if it's a K or an R species, you would have to say, well, it has these characteristics that make it an R, or these characteristics that make it a K. Okay. So what about the clownfish Tanya is asking? Okay. It's an animal. That's perfectly fine. Is it a K or R, or is it a blending of the two? Let's ask our panel tonight. Ladies and gentlemen, is the clownfish K, R, or a blending of the two? Tanya's going to go with blended. Dakota's got the K. Blend. Okay. Now, if this is an FRQ, if they say, is it a K, R, or blended, they will almost always say explain. Okay. So don't forget that part. Okay. So Tanya says they're going to have lots of offspring. Yes, we all saw Finding Nemo, or pretty much all of us saw Finding Nemo. They only live in a specific place, which is the sea anemones of the coral reef. They have lots of care. Okay, so in this case, we can see that, well, they all died because of a barracuda. Right? That wasn't the parents' fault. Okay. So if the question asks if species is a K or an R, the answer, let's see, the answer could be that it has characteristics of R and K. I would have them pegged as being question writers that say, is a K or R, and they're going to give you examples in a reading about, it happens to live this long. It usually gets this big. It has this many kids or whatever. And those characteristics would be used to determine if it's K or R. They're not just going to randomly say, hey, what do you think about kangaroos? Okay. I think they're going to give you that little reading paragraph so you can get some information out of it. Okay. But always make sure that you use the information they give you in cases like that. Does that make sense, Juan? I have to comb my beard. I'm so pretty. Alrighty. You could use the attributes of the other type as counter argument. Yes, you could, most definitely. Okay. Sea turtles, like this guy right here, this lovely little sea turtle. Okay. Very long life, very large size, has lots of kids, few live to maturity, but they still have lots of kids. Okay. So it's on that spectrum. Is it more towards the K or the R? I'm going to put it more towards that K species than the R, but you could argue it the other way as well. Okay. So use the information that they give you. That you almost always will help you out. Okay. So could these turtles? No, I don't usually see them as an invasives. Uh, yeah. Do y'all see something? Do y'all see the turtle on the screen? One of my people's. Y'all can't see nothing. Just the title slide. What the? I've been going through this whole thing. Oh no! You see a table? Oh man! Oh man! Oh man! My wife is streaming too. It's a table. You guys are back on the. Let's see. Let's see. Let's see. Let's see. Which table are you guys looking at right now? K and R. Okay. Blank K and R. Daggum. Okay, this is no fun. Alrighty. Let's see. Let's close this bad boy down. I don't want to close the whole video. Yeah, I want to close this. All right, give me a second. Let me see if I can't fix this real quick. Let me close down mine. So you should just see. Do you guys see just my face right now? Okay. All right. Cool. Let's try this again. Share my screen. Now y'all get to see what I get to do as a teacher. La 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 la. There we go. Close the message. Make it bigger. All right. Now what do you guys see? The turtle. Sweet. Okay. Anytime. I'll tell you this. Next time I go to a new slide, I'm going to tell you a new slide. You guys tell me if I've caught up. Okay. If not, then I'll quickly do that again. Oh, good. Whew. Yes, I will go right back to that chart right now because it's important. Oh, where'd it go? Alrighty. We'll put the whole chart back on there. There we go. Whew. Terrified for half a moment there. Awesome. Yeah. So, like I said, I will. That's a good thing for me. Thank you, guys. I will tell you when I'm going to the next slide so that way you guys can tell me if things are popping in or not. All right. Yeah. Ooh. Lots of great. I like those. Like I said, I try to add a little humor. I want to, if I'm having fun, I'll tend to remember things a lot better. Think of it. Memory is attached to emotion. Okay. Yes, that's usually how it works out in my family. I lost a finger last week because I touched my son's chicken nuggets. Yeah, it was terrible. It grew back. There we go. Yeah, so we're good. But it was scary for a moment there. Yeah. If we have time, I have a story about my oldest son and how he checked to see if daddy had a fake finger or not. Anyway, like I said, but that's at the end. I don't want to take up too much more time because dang it, something already happened to my stream and we got to keep going. Okay, I'm going to a new slide. Do you see the turtle now? Okay, cool. All right, sweet. Okay, so like I was saying, the turtle's good right there. Okay, so I'll leave this up here for a second just so y'all can, breathe that in. Okay. Again, it's a spectrum that K and the R. You can be more towards a K or you can be more towards an R. Or in some cases, like the trees and these, some of these sea turtles, they're kind of in between. They have characteristics of both, and they act like an R species in some locations or instances and R's in other. Okay? So, thumbs up if you're good, and I can go on to my next slide. I got one thumbs up. Close enough. It says, yep, that works for me. That's right, Tanya. Yep, we're good on that. And we got a whole bunch of thumbs up. Woo, woo. Tanya says turtles lean towards K, but in between. Tree leans more towards the R, but in between. Exactly. Yeah. Excellent understanding of that, Tanya. Thank you for that summary. Okay. So widespread R? Yes. R's are usually very widespread. You can find them almost anywhere because, again, they're more like a generalist. And clustered are K. Yep, we can think of that way as well. Nice close-knit groups. All right, so do you guys see the survivorship curves on my screen? Please. Sweet. Okay, good. All right, so survivorship curves. That kind of goes into the K and the R2. Basically, these are looking at the percent of organisms that survive to a certain age group. And yes, in this case, our twos are going to be more of those blended too. Again, we're looking at number of organisms in a population that reach certain age groups. We have the 3 different curves. Usually your type 1s are going to be, majority of these ones will make it to old age. Like we see with humans, we're rather long lived. We're getting into our 70s, 80s, even up to our hundreds, which is neat. I like that. When you're looking at, and they're also, all the type 1s are Ks, K selected. Type 2, it doesn't really matter their age versus their mortality. So there's an equal chance of life and death at every age group here. They tend to be more of a K than they are an R. But again, it's kind of that blending. We got that spectrum going on. And of course, our type 3s, very high mortality. They have lots of kids, and then most of them perish very, very quickly. And so now you're just going to have a few that live, and they could live to a long age. But again, there's only going to be a few of them. All right, they're going to be more of that R selected. Again, think of, in this case, we have the frog is on there. Has lots of little tadpole babies, but they don't all survive. Fish, they don't all survive. Cockroaches, they don't all survive. That kind of thing. There's only going to be a few of them that will live to reach a very old age. And this is what we call our survivorship curves. My favorite lab actually goes right along with this. It's called the bubble lab. Is where you blow bubbles, and one group tries to nurture their babies and tries to keep them up in the air. One group blows the bubbles and just allows them to do what they need to. That's kind of that type 2. I love, yeah. Oh, you did an AP Bio? Oh, see, it's a great lab. Yeah. So you know what I'm talking about. And then like my last group, only if it reaches past a certain mark are they allowed to help it at all. So that kind of goes into that type 3. Okay, let's see. We would purposely attack. Yeah, actually, the first year I did it, we had a predator, and she was very upset with a group of guys that was next to her group. So she just kept popping all their little bubble babies. We kept it. It was data. So I tell my students the only way to have bad data is if you falsify it, or you mess it up on purpose. So it was data. We kept it in there, and you're right. That's exactly how nature works. There are predators out there. So. All right. Ready? Next slide. You should see carrying capacity and population growth. Pretty please. Yes. Okay, cool. Good. I don't know. I'm just terrified now that I'm going to be talking and there's going to be nothing on the screen. All right. Have you guys seen this kind of graph before? Sorta. Okay, good. Sorta, I'll take. This is known as a logistics curve, okay? Also, the logistic, also known as an S curve. Yeah, usually there's more lines, and I have one, next one I have another slightly different line on here too. If you'll notice that next to where it says carrying capacity, I have a K. That K does not go along with like a K in an R species, okay? You're right, the next one is the J curve. That K stands for carrying capacity. So if you want to think of it, carrying capacity is the amount of material, whatever it may be, water, shelter, air, whatever, in a location. And that material is all that you have for that area. And so now your population is kind of dependent upon that. So it gives you your population growth. Yeah, I can see confusing those Ks. I totally can see it. Now, when we're looking at this, though, don't think of like a K and an R species, okay? We kind of separate those two, okay? I will try my best to make some connections to certain labs, although I don't know what labs you guys did, especially where the design and investigation FRQ. Yes, as I'm getting more information on how to put that in there for y'all. Thinking if we can put one in here this week. Now, this week's information doesn't really go well with it, but when we get to the soils, it will do that pretty well. So I will be getting it in there for you, Juan. Okay, I'm not going to leave y'all hanging. Okay, y'all are my people right now. All right. Yes, I love the bubbles lab. Okay, so now let's look at this lab, not this lab. Let's look at this graph right here, because one of the FRQs does have you interpreting a graph. So when you look at this, obviously we just have the graph on it and the little dotted line, population over time. If you look at the very bottom, it says slow growth. So you can see that it's just very slow at first, a little bit increase over time, and then as it goes more and more vertical, we get fast growth. So right there in the middle of that S, right there in that middle, that is the absolute fastest growth. After that, it starts to slow down. And why is it slowing down when it reaches carrying capacity? Think of it this way. Why is it slowing down why is the population growth slowing when it reaches carrying capacity? Exactly, Jacob. Thank you. Resources are being more scarce. Exactly. Okay. And so in this case, this S curve, this S-shaped curve, logistic, you have that sound in there, logistic, it reaches carrying capacity and kind of just forms right along with it. Now, our next one, oh, sorry about the earthquake. Our next one is the exponential or the J curve. And we call it a J curve because it goes up. And in ideal conditions, it will constantly go up exponentially. Okay. Logistic is basically is based on log 10. So don't worry about that. I hate when you guys did the bubble lab, did you guys have a funny looking graph that had the graph paper that was basically it started to get bigger, 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 and then it collapsed again and get bigger, bigger? Okay, so that's what we call a logarithmic graph paper. And it's really not fun to explain. I don't even think my brain functions well enough to think about it. But we just call it I usually just go with S curve and J curve. Okay. You have barely any bubbles. Yeah, I had to make my own bubbles one year. It was kind of fun. So don't worry about the term logistic, but always know that the J is an exponential growth. And without any resource caps, it'll constantly go up. Okay. But what happens when you do go above carrying capacity? When you overshoot, what do you see happening on that graph when you overshoot? When you have more population than what resources you have, than resources that you have to sustain them, what happens to the population? There's a dieback, there's a die-off, there is a collapse. Sometimes that collapse can be permanent. It just shoots all the way down, and then the population is gone. Or in this case, what we have, it shoots up and goes down below carrying capacity. And now, hey, there's more resources than we have organisms. We can have more kids. And it goes up and down, up and down. I'm not sure it's not really a lab. It's more of a kind of a worksheet. It's looking at the moose and the wolf population dynamic. And how as one goes up, the other one tends to go down. And then they basically flip-flop back and forth. Have you all seen that before? Have you done something like that? I've done it with my freshman biology students. So that's kind of what we're looking at here with that exponential growth, and it goes up and it drops back down. Yes, I've done it with my I didn't do it this year with my AP bio students, but I have done it in the past. Oh, okay. So right there, Juan, I'm trying to help you out, trying to connect certain things. You can look those up as well. The wolf and moose population lab. Oh, I'm trying to remember the name of the island, but if you just look up moose and wolf graph, you can pretty much find that. So, all right. AP Bio does have, at least these earlier units, it has lots in common. But pretty much after this, it dies off. Yeah, it's basically all the ecology stuff, like Samantha says. That's it. So like I said, after this, there's not a lot of interaction between AP Bio and apes. So we start going to more earth sciencey stuff. Oh, that's good, Tanya. You're feeling better about that. Oh, excellent. Okay, so when your population is bigger than the resources, then you tend to have a die-off. You could possibly go back up, or it could be collapsed depending on how severe that die-off is. All right. Okay, going to our next one. Another graph. Okay. All right, what's your question, Tanya? What you got for me? While Tanya's stopping your question, do y'all see the Malthusian catastrophe? All right, so Tanya's question says, why does the K line dip for the J line? If the resources are not replaceable, then that K line, your carrying capacity, could dip down. Think of it this way: if water could not be recycled, then our water carrying capacity would curve down. Or again, if it's something that is again a limiting factor or in a limited amount, it could curve. It doesn't always, and I rarely ever show that. I always think of it that there's always more of the resources than the population can handle. Okay, but that was a good question. I like that. You notice something on the graph again. That's something that they're looking at on the questions. They're going to be asking you to interpret the graph. So why does the line's carrying capacity line dip at some point then? That's hard to say on that one. So it could dip again if resources become scarce because they're being overused. Again, there doesn't really have much. It just says time down there, so we don't know how long it took for these to actually happen. You can kind of think if you thought about the carrying capacity of like coal. So obviously we're not dying because of the coal, but that coal line is starting to curve down if you want to think of it that way. Okay. All right. So it just depends on the species and the resource at the time. Yeah, whatever resource it may be. All right. Do y'all see on the screen a new graph? It says Malthusian catastrophe. Awesome. Jacob, you're in my brain. I love it. So Thomas Malthus came up with this. It was a very long time ago, well over 100, 200 years ago. He noticed that the human population is an exponential growth. So again, we got that J curve going. But, okay, the food line is what we call arithmetic, or I don't think that's how you say that. The food line is what we call a linear growth. So that's a very straight, solid line. And what we notice is that if you had that point of intersection, that's where what we call the Malthusian catastrophe. Where at this point, now we're going to start seeing a higher population and a shortage of food. So it's kind of like us hitting that carrying capacity. And here's the thing: we have hit that Malthusian catastrophe, or we've come close to it numerous times. And yet, as a species, we are still here. So, why is that? Again, population growth is exponential, whereas the food production is linear. You know what? I do not think I understand those terms, geometric and arithmetical. I don't use those terms, so I'm not sure if I can answer that question for you very well, Tanya. All right. Is point of crisis the same as Malthusian catastrophe? Yes. Yeah, it's a synonym for it. Jacob's right there. So when we have better sources of agriculture, better ways of making our food, one believes that geometric is exponential. Thank you, Juan. When we bioengineer food, stuff like that, we have abilities to basically extend or change the location of our point of crisis. And that's what my lovely little blue line is right here. Better food production. Let's see. When we started farming, oh, that was just brilliant. And then when we started monoculturing, we can make a whole bunch of corn in that little location. So that helped a lot too. When we found ways to make better fertilizer, every one of these little technological increases, it didn't change the slope of our line, but it shifted up the line of food production. So now we have a new location of our crisis. Yes, you're right on that. Population growth has slowed in lots of places because of the going into stages of 3 and 4 of the demographic, the DTM. That's my last slide. Transition model. There we go. I'm going to have a hard time thinking today. Exactly, Tony. This will determine when technically a species would hit their carrying capacity, their point of crisis. Exactly. So, again, it's with that J curve, it goes all the way up. We'll go back. There we go. That J curve is going up, and right when it hits that carrying capacity, that's our point of crisis. And so that's what Malthus was talking about when it comes to the human race. We are exponential growth. We have what seems like an unlimited amount of resources, but what's going to happen eventually is it's going to be our food that's going to cause us to have a catastrophe. And so when it hits that line, okay, when it hits that line right there, that's when we're going to have that uh, point of crisis. So what we've done, we've shifted the lineup, and so now it'll take us longer to get to that point of crisis. It's an upper limit of population and food. Yes. Okay, so this determines when yes, point of crisis. So since the population production line went up, the carrying capacity went up. Exactly, that carrying capacity can shift up and down. Okay, it's an upper limit if you want to think of it. And once we cross that upper limit, just like we saw on the last graph, we're going to have a die-off because there's more population than there is resources to sustain them. Okay, and Thomas Malthus was thinking that it's probably going to be food that does this for us because there's only a limited amount of area that we can grow food. Okay, exactly, Tanya. Checks and balances, but in nature and not in the government. Exactly. All right. Alrighty. Next slide. Is it blank? Yes. Okay, cool. Okay, so let's talk about density-dependent factors and density-independent factors. So I'll give you an example. What does it mean to be density-dependent? A density-dependent factor. What does it mean by that? It will change intensity depending on the density of the population. Excellent. Predation is an example of this. Thank you, Jacob. It depends on how high the population is righteous. You would be more worried about predators if it was just you and your friend, whereas if you're in a huge crowd, okay? So that's why a lot of organisms like zebra, they'll travel in herds so that they can reduce the amount of predation. They know it's going to happen, but now there's a less of a chance that it'll be them that gets hurt. Alrighty. Competition is also density dependent. If it's just you and one other person taking the test, whereas you and a whole bunch of people, it kind of changes the competition. Or, it's a family, I have a family of three, myself, my wife, and my youngest son right now. When it comes to dinner time, I told you, I lost a finger. I touched the chicken nuggets. So if there's more people, there's going to be more competition, that kind of thing. Parasitism. Actually, let's go to this one, disease. That's what we're looking at right now. Disease is a density dependent. And so what has our governments told us to do about our density as a human population? Isolate. Again, reduce density. Exactly. Going back to Saba, yes, food availability. That goes into the competition, space and stuff like that. We are maintaining our social distance, and we do that so that hopefully there will be less of a chance of us to basically pass on disease. Okay, if we stay in, and before it was our severe social distancing like I have, we were told no more than 10 people in a room. Okay, but even now we're trying to even separate even farther than that. Stay at your house, make sure that if you do get sick, it stays there and it doesn't get traveled out. You have friends who haven't. Wow, Tanya, that's not nice. Text them. Have you texted them first? Give them a text and say, hey, I missed you. Okay, we'll try it again. 20 each. I'm sorry for that. We're here for you. I'm your friend. I'm not going to give you my phone number because I just use my phone to play TikTok videos. But that's all right. All right, so density dependent right there. Let's look at the other one. Density independent. Whereas if you got the density dependent, you probably get the density independent. Density independent doesn't matter how big your population is or how many are there. That's it. Okay. Awesome, Saba. I'm really glad to hear about your like and comment on your TikToks, right? Like I said, I don't make them because I'm kind of scared. Nobody needs to see this. Y'all paid to see this, and that's your problem. I'm happy for it, though. All right, so density independent factors. So looking at this, natural disasters, does it matter? Does a thunderstorm care how many people are there? Not really. Thunderstorm is still going to happen. Another example is pollution, weather and climate. It was cold today. It hit like 53 degrees. I was shivering when outside. You were starting to reel out about abiotic. Yeah, a lot of these things are going to be abiotic factors. It does not really matter how many things are there for these to matter. You're right. It's a lot of abiotic factors. Awesome. Okay. It's going to rain whether you like it or not. Well, if I have a group of 100 people, I don't care. But I'm going to have a wedding. It's going to rain at my wedding. Clouds don't care. Clouds are like the honey badger. They don't care. Yeah, I'm North Texas, so yeah. Now I was born in Canada, so it 53 degrees is like woohoo, spring day, kind of like you saw right there in Wisconsin. But yeah, I've been in Texas since I was in the fourth grade, so 53 degrees is like, and and I have nothing up here to keep me warm, so I have the chin cover. At least part of my head will be warm. All right, let's go on to the next one. We're going to talk about age structure diagrams. I want to get to my math, so we're going to hopefully. How many of y'all? How much of y'all covered on age structure diagrams? Well, very cool. I hope you have good results with your chin coverings. Age structure diagrams themselves basically look at population growth rates for a specific. Usually, we're looking at countries. Okay. You can look at them. Yeah, world geography. APUSH is a good example of this too. Not APUSH. Hugo is what we call it in my school. Human AP Human Geography. AP Hug. We look at comparisons of males and females, and of course, they're usually in age bars. Age usually keeps them in 5-year gaps. So the first couple are going to be infants. You go to your adolescence, reproductive age, and then post-reproductive. Okay. And yes, you're split by gender. So here I happen to have 3 of them right here. Okay. These are 3 typical ones that you would normally see. Again, they're split by male and female. Usually we have, actually, I think it's usually females on the left, but they will almost always label them because they're a graph. They should be labeling these things. Now, what do you notice about the very first graph in its population growth? Is population growth increasing, decreasing, or staying the same? Thank you, Tanya. She says it looks very similar to stage 1 of the demographic transition model. It is population growth is not in this case decreasing. Actually, this one is rapidly increasing. And the reason why you can tell this is if you look near the middle to lower, if you have a wide base to your pyramid, that population as it ages will go up and they will have more kids. So it gets from this to this and keeps constantly getting bigger and bigger and bigger. Okay, so if you look at the number of adolescents, and even if you just look at the number of children, the adolescents and the infants, if that's really wide, wider than the rest of it, you have that true pyramid shape, that's going to be rather increased population growth. Want to ask the gaps may not be intervals of 5, right? Yes, they may not be intervals of 5. They could be intervals of anywhere between, I've seen 3 to 6, but on average, they'll be 5. Or they'll even tell you what each bar is worth as well, too. Population pyramids with a large base have a high CBR, exactly, which is accrued birth rate. Okay, increase in the population. Alrighty. Don't facepalm. It's nothing wrong, Tanya. You take a chance, we correct you. No one's making fun of anybody. Okay? So, take a chance. If it plays out, awesome. If it doesn't, you learn. I tell my students, they say, oh God, I feel stupid today. No. Stupid people don't learn from mistakes. Smart people learn from their mistakes, right? Stupid people are like, oh, I'm dumb. And then they don't work on it after that, okay? I'd rather not test that. Hey, don't worry about it. That's what you're here for. That's why I'm trying to help you out. To kind of give you a reminder. Now, let's look at this middle one. Notice his base is not very wide. It kind of narrows at the top rather quickly, okay? But if you notice, the sides are really straight. So, population growth, increasing, decreasing, pretty much staying the same. What do you guys think? Slowly increasing or staying the same? Yes, in this case, you can make an argument for both. I have it, it's rather stable. It's a very slow increase, but it's nothing nearly as rapid as what we saw in that very first one. And then what is happening in the poor graph number 3? Yeah, it might be Italy. Although it's more the older people. Yeah. So very similar to Japan. Germany is similar to this too. They're having a decrease. Germany up until a couple years ago was rather stable. I think they're going through a decrease now. Also, again, since we're able to look at the two genders here, the males and the females, what do you notice about the difference between the male and the female on this third graph? And one, I'll answer your question here in a minute, I promise. All right, there's more men than there are women. Okay. So look at that. Yeah, we can see that there are more more males than females of the younger generation. All right. Could be very similar to China, although they've had a population explosion. But yeah, again, you are interpreting the graph, and that's what I need y'all to do. Okay. Interpret, what do you see? Don't make any guesses, but what do you see? Okay. All right. So going back to Juan's question, how does staying the same work? What you're doing is you are basically maintaining no population growth by having what's called 2.1 kids. Every couple has 2.1 children, and that is able to maintain your population without any growth and without any decrease in the population. It'll stay the same. Okay. Oh, my back. So, some of y'all in here were talking about the different demographic transition theories. So we'll get to that here in a minute. But first, let's talk a little bit about total fertility rate. Oh yeah, yeah, that's my kid's hand. Yeah. Say hi, Lefty. All right, so total fertility rate, also known as TFR. Okay, the total number of children born to a woman in her lifetime. Okay, once she reaches reproductive age, they start counting children, obviously, because you can't have kids before your reproductive age. Ta-da! That's how smart I am. Now, it can be affected by this. Now, pay attention to this because I've seen this on tests in the past. An easy way to talk about total fertility rate is the age that a woman first has their first child. So if you wait until later on in life, your total fertility rate is lower. If you have kids at a younger age, you tend to have a higher TRF. Okay. Yeah, I thank you, Jacob. I just can't say that word because I can't pronounce it very well. Fecundity. Yeah, see, that's how well I said it. But yes, it's exactly what we're looking at. Okay. You never understood why it was the number of kids a woman had, not a man? Because here's the thing. Men can constantly go around and have lots of kids. Okay. But it's the mother who raises them, the mother who births them. So we're going to go with the mother. You could look at it almost either way, but the fertility rate is basically how fertile it is, how often they can reproduce and have children. Okay, so we're looking at a female. The males, they can reproduce technically. I believe it's once a day if you're looking at humans, whereas females, it's every 9 to 11 months. Okay, so if you were looking at the TRF of a male, that's way higher than it would be with a female. Okay. Well, I'm not going to comment on that one. Total number of kids per family, not favoring either gender. Okay. Yeah, they're not favoring the gender, but it's total number of kids by the females. And that's going to be one of those Hugo things. I was never in that class, so I do need to go on a little bit more, but here's another thing that affects them is their educational opportunities. We've found that by keeping women in school, keeping girls in school, they educate themselves. They're higher educations. They have more abilities to go into like a workforce. Family planning is better too. Again, better work opportunities. Yes, and yeah, you don't just educate the females, but if you educate the females first, they can tell the guys no and stuff like that. And yes, in our schools here, we do educate both the males and the females on basically family planning. Okay. And let's see, what else do I have? Oh, there's government policies too. Okay. And social and religious edicts. So China had the policy of the one child per family, although they have since rescinded that. It is still out. It was out there for quite a lot of time. Oh yeah, Tanya, we're trying. I'm all about getting rid of stereotypes. I'm all about that. Okay. Social and religious edicts. There are certain religions and sects, SECTS, not to get confused, that mandate X amount of children. Okay. In China, they did prefer the males over the females. That's why you'd actually see quite a few age structure diagrams of China where there's very few or a great reduction in females at the lower ages. That is right, Jacob. There's lots of guys running around without girlfriends to tell them, quit doing stupid things. Why are you doing that? Oh my God. Okay. All right. Total replacement level fertility. So that means we have zero population growth. Again, each couple gets 2.1 kids. And then here's something that we don't like to talk about, which is the infant mortality rate. The number of, and yeah, there is a lot of places that have talked about rape and assault because there's, again, fewer women. And if not fewer women, less education of men of how to treat women properly. All right, so infant mortality rate is something you look at, is the number of children that die before the age of 5. Why do we talk about those? Okay. One, so that we can correct those, looking at better hygiene, medicines, education, quit using kids in the workforce, that kind of stuff, which the U.S. did up until, the early 1900s. Okay. So that brings us to a little bit of math. It does determine how developed we are. All right, so I do want to get some math into y'all a little bit before I go into the last bit. Oh, wait, go back. Okay, so look at this. Crude birth rate. Okay. Yes, Jacob already hit it. We are good on that. Crude versus crude death rate. Yeah, I have that's on the next half of the slide. So look at this. I'm going to do a little math with y'all. All right, if you got my email, I asked you to either bring a calculator or at least bring something to write on, and I'm going to show you this math. So crude birth rate, or CBR, is the number of births per 1,000 people. So if there happens to be 204 births out of a population of 13,530, I just made those numbers up. If you take 204 divided by 13,530, you get 0.015. Actually, I'd say 0.0150 something when I worked it out. Okay. Yes, I have doubling time on here too, Tanya. Don't worry, I get you. I cover it. I gotcha. So if we transfer that into a percentage, that'd be a 1.5%. So if you could say that the birth rate was 1.5%, or you can say that the crude birth rate is a 15. So if you take that 0.015, and again, it's per 1,000 people, so we're going to multiply by 1,000, move your little decimal over, that 0.015 turns into a 15. So a 15 CBR, crude birth rate. So I had this question on the screen so far. Hopefully you guys have already started it. A country has a crude birth rate of 34. So I have my CBR of 34. If there's 15,267,951 people, how many births did they have last year? All right. So here's how I worked it out. I always like to look at, what's the formula first? Okay. So my crude birth rate is the birth rate times 1,000. So my crude birth rate was 34. My birth rate times 1,000. Okay, keep going here. So if I take my birth rate and I divide the 1,000 out, I get 0.034. Sweet. Now, what do I do with that number? What am I going to do with that 0.034? Oh, no. Look at the example. We have our population. Exactly. We're going to multiply by population because we have the population. We have this rate. So now, if we multiply them out, we are going to get the number of births. Exactly. So this is kind of how you would expect to do it on a AP exam. Everything I've done so far is meaningless, but that last little part right here, all right, where it says births over whatever, okay, should be, let's see, what do I have? 519,110 peoples. Yes, and with that 0.00 or that 0.334, Jacob, you can round it to the nearest whole person, in which case this it would be 519 and 10. Okay. Tanya, you're not very wrong. We just have to figure out where you made a mistake. Okay. So go back, look at my births. We have my CBR is 34. We converted that into a birth rate. So it's 0.034. And now we're going to do algebra. Okay, so multiply both sides by that 15 million, that population. So 0.034 times 15,267,951. And you'll get that 519,110. Okay. Yes. Hopefully, it's hopefully whatever math, if they decide to give us math, it won't be any more difficult than that. Just basic algebra. Now, what I heard is so far on the first FRQ, you are not needing a calculator. That doesn't mean it won't be math. It just says you won't need a calculator. Yeah, if you have it, just it's okay, Tanya. We got you. I can tell you right now, what I did is I Googled crude birth rate or APES crude birth rate, and I actually found a somebody's not exam, but a worksheet online, and I just changed numbers for myself, and it already had the answers on there. So you can do the same. It's perfectly fine. Oh, you misread the question? Oh, that's even better. I call those silly mistakes. I totally prefer silly mistakes over I just didn't understand something. Okay. All right. So let's look at my next one. Excellent, Tanya. Thank you. Yeah, Jacob, you're going to round down. If it's 0.5 or above, you can go above it. You can round up. All right, crude death rate. Same thing, except for it's now the deaths out of 1,000 people. They haven't been giving us the crude death rates. They've just been telling us the number of people that have died from the COVID-19. Okay. But so I have my numbers right here. And when I did this, I tried to make it so that the numbers you could easily get without rounding a whole bunch. I've seen that happen on the AP exam, though with the use of calculators now, they looked at having more real world numbers. Okay. So same thing, deaths over population gives us a rate, multiply that rate by 1,000 and you get the crude death rate. So a country has 1,256 deaths last year. The country's population is 97,000. Yeah, I'm sorry that we have to talk about this, but it makes sense for me in a minute. And I know I've gone over my time. I did it last week too, dang it. Alrighty, Jacob says he's already got the answer. What's the crude death rate? Same thing right here, except for we're just going to do deaths divided by population. All right, is our doctor or death rate right there. So it comes up to 0.01289 or 0.013. That works for me. Okay, multiply that by 1,000, gets your crude death rate of 13. Careless errors are perfectly fine, dude. Like I said, they would probably take that 12.89. They usually have a range of numbers that they would accept. Okay. Oh, wait, I just saw your answer. Yeah, that is a slightly different error. That's a lot more people's, a lot higher death rate. No, Tanya, you're good. I was accidentally mixed up your answer and Jacob's answer, but that's okay. That is okay. So don't get scared by the math, okay? The math is not a problem. Can you show us our steps again? Not a problem. Here we go. Okay, so there's my deaths over the total population. I know that happens to be my death rate. If I take my death rate times 1,000, then I get my crude death rate. So I divide those numbers out. So 1,256 divided by 97. That is a 97. Okay, not a 91. Okay. I would actually round my number to the 13 there, Juan. I wouldn't leave it as 12.89. I would round to the 13 in this case. Not a problem. All right, so it comes out when I divide 1,256 by 97,434. I get 0.01289. I can round that to 0.013. When I multiply that by 1,000, because death rate times 1,000 equals crude. Boom. How's that worked out? Let's see. Tanya. Yes, that is, if you're going to type it out on the computer, that is exactly how I would have done it. Exactly like that. So usually what we're looking at on a math question is the setup. So if you have what's on my screen right now, that is your setup. It is labeled, and now you have an answer down below, and CDR, which is total death rate, that itself is labeled, or you can just say 13 people that were burned too. Okay. So always show your setup and show your answer. Those are the two parts of a math problem that you would get the points on. And always label everything. Okay. Again, we're not sure exactly what kind of math we're going to see this year, but I want to make sure you're prepared for it. Alrighty. So population growth rate. I'm going to put this up here real quick. And I may have to, I'm probably going to hold off on, the demographic transition until next week, because I do not want you guys to, dang, Jacob, you're getting fast. I don't want you guys to hang around too much longer. I don't want to take up your time too much. So I'll postpone it to next week if I have to. Okay. Growth rate is a doubling time. Yeah. So population growth rate in here, you're looking at all the people coming in. So crude birth rate plus immigrants. And we subtract, oh yeah, we can stick around. We subtract everybody that's leaving the country. So that's the death rate and emigration. And we're going to divide this by 10. And that gives us our rate itself. Okay. So the town of Fremont has a crude birth rate of 34 and a crude death rate of 20. What's the growth rate of Fremont? Well, again, 34 minus 20 divided by 10. So 34 minus 20 gives me the 14. 14 divided by 10. Again, I don't use a calculator on this. I just move my decimal over once. Bang, gives me 14%. That is my growth rate. So every year, your population would grow by 1.4%. Let's see. So it equals 14. That goes down to 14 over 10. Yes, Tanya, I would do just like that. Yes, ma'am. That is how I would type it out. Excellent. All right. So now what they'd like to do is use the answer from one question to go into another one. Probably not going to do that this year. Not sure, though. The rule of 70, also known as doubling time. So you take 70 divided by your growth rate. So you happen to be 14 years old in this town of Fremont. What age will you be? That's okay, Tanya. What age will you be when the town doubles its population? Jacob's quick on the answer. Everyone else try it out real quick. Old. You'll be older than 14. All right, so set it up. Okay. 70 over R equals years. 70 divided by 1.4, because we used the population growth rate from our previous question. 70 divided by 1.4 gives me approximately 50 years. Okay. Thank you for your correction on there, Tanya. Again, Samantha has it right there too. So now we're going to add your age. 14 plus that 50 years, you'll be 64 years old. Just as Jacob showed us earlier. Awesome. Oh, yeah. So you feeling confident now? You feeling better? All right. Take our little wins and just go for it. All right. Well, hey, you know what? Forgetting something means that you had it in your brain. It will come back to you. All right. So here's the very, 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 very last thing tonight. Exactly. Samantha's right. You understood the important parts. Remember, we're not trying to get every single point on our FRQs. We're trying to get as many points as possible. Okay. Significant figures are not used. Yeah, we rarely ever see those. Okay. AP biology, yes. APES, not so much. You're pretty good. Okay. All right. Here's the very, very last thing. Oh, chemistry too. Yeah, most definitely chemistry. Demographic transition. I'm going to leave this on the screen. Think of it this way. In stage 1, you have a very low population because you have a lot of death. Even though you have lots of kids, high birth rates, you also have a high death rate. They don't live very long. So you're looking at like Amazonian Tribes right here, very low population, very small tribes. Okay. Is there a study guide for this unit? Yes, there is. I made all the study guides a couple weeks ago. It should be on Fiveable. All right, they should be there. If you go, I don't remember exactly where I should go. Let me finish this off and I'll go back to that question for you, Emma. Stage 2, we see our population increase because our death rate starts to decrease. We still have lots of kids because, dang it, we're still scared that they may die, so we still have lots of kids. But the death rate's going down, so maybe we're getting a little bit better education or better food, medicines. So our populations start to go up a little bit. Stage 2. For us, we're thinking of this as like in the 1800s for us. Now, get to stage 3. Death rate is way low. By the end of stage 3, it's almost, it's as low as it possibly can. We have urbanization, exactly. Okay. We don't need as many kids to work for us. Okay. And so our birth rate is low because, again, who has time to have kids? We're in the factories. We're working. Okay. We've got jobs to go to. And our population is starting to go up because, again, very few people are dying. Even though we're not having as many kids, we still had kids. If you look at the age population diagram, there were still kids. So our population is still going up, but it's starting to taper off and steady out. By the time we get to stage 4, very few children are being born. Very few people are dying. Our population is as very high as it could be. We think of this as the post-industrial. Kind of think of it as now for the U.S. Okay. There is a stage 5 that AP Hugo would look at. And that is when the population starts going down because, Japan is one of those examples. Because you aren't having very many kids. Your population is getting older. So the population starts to go down. And it will, again, we don't know if it's stage 6, but we do see a stage 5. We usually in APES just go from 1 through 4. Okay. Yes, increasing death rate because of the aging population. Exactly. Birth, birth, yes. Okay. No, stage 5 is not going to be on the APES test. We rarely have ever talked about that. We usually just go to the stage 4. Hugo, our AP Human Geography, you would probably see that stage 5, but we don't do it here. All right. I know I've already taken 12 minutes more of your time than I planned again, just like I did last week. Dang it, I'm not very happy with myself. I'll have to streamline a little bit better. But again, take a screenshot of this. This is what we know for our AP exam. Look at your time frames. Okay. I'm trying. I thank you for that one. I do try to do a good job. I don't like going over my time limit. I appreciate the quality. I really do appreciate y'all thinking it's quality. Okay, thank you very much. Thank you. Again, you're looking at 2 different FRQs. You are going to be doing it on your own device. Whatever device you do it on, of course, is what you have to upload it. You'll be given 25 minutes for your first question, and then 5 minutes to upload your answer. 15 minutes for your second question, and another 5 minutes to upload your answer on that one. Again, whatever device you download it on, that's what you have to upload it on. Even if you handwrite it out, that's perfectly fine. Take a picture of it. Make sure it gets to whatever device you downloaded so that you can upload from there. And what they said is in late April, so actually just about 2 to 3 weeks from now, they are looking at some way to practice the ability to upload your answers just to make sure everything works out perfectly fine. They're trying very hard to take care of their students through these weird and crazy times. Okay. I am going to talk more about design the investigation and the analysis of the environmental problems. That very last stream is the night before the AP exam, and that's all I'm going to cover is that stuff. I will put a little bit more into next week's and stuff like that, try to get a little bit out there as I get to it. But again, if you can, attend this Wednesday's 2016 FRQ review of it so that get a little bit more help on those FRQs, okay? Yeah, the time's a little weird. I know this, but think of it this way. If you happen to be in Europe, you are taking the test way, way late at night. If you happen to be in Hawaii, look, 10 a.m. Oh, it's just crazy. Some people are going to be staying up a very long time to take their test. So, But, the whole test itself is no more than 50 minutes long. Okay. All righty. How did I do tonight? Good times, bad times, happy times, sad times. Great times. I take that. Not a problem at all. I do appreciate y'all being here with me. You have time you can spend elsewhere doing other things. I'm glad you were here with me tonight. Thank you for your questions. Thank you for your comments, and thank you for everyone that that learned something. That makes me feel good as a teacher. Okay, I'm here to help you guys, but really, I'm just in it for myself. I just like all the admiration and praise and knowing that I did a good job. I'm joking about that. Anyway, I want y'all to have a good evening. I hope to see y'all next week, and I hope to see y'all in the streams on Wednesday this week too. Okay, they'll go over the structure diagrams a little bit better, in a little bit more detail than I did tonight. Okay, so y'all have a great, wonderful week, and I'm going to see you next week. All right, take care until then. Bye, y'all. And again, of course, at Think Fiveable, we're here for you. Okay, we're always here for you. We're just a click away. Okay, ladies and gentlemen, you guys have a wonderful evening. You've been great tonight. I'll see you next week.